Okay, so the next topic for my college students would be normal curves. So, what are we going to talk about today? A normal curve is something that, what is a normal curve? What is the empirical rule? Which some people call the 68, 95, 99.7 rule. How do we use the rule to find different percentages of probabilities? How do we find the percentages of probabilities using the z-square formula? How do we use the formula to find intervals or percentiles? And we're also going to talk about how to use StatCrunch to also do this as well. So let's talk about what a normal curve is. And so, bam, that's what it looks like. A normal curve basically is known as a bell curve. Okay. A normal curve is a curve that is both symmetric and unimodal, which we talked about in both instances already. Really important: the mean, the median, and the mode are all the same, and the standard deviation controls the spread. So the big thing about this is with a bell curve. If your teacher ever tells you that they grade with a bell curve, you probably want to get out of that class, because in a bell curve, since the mean, median, mode are all the same, the most grades are going to be right in the middle, which is a C, and then there's going to be an equal amount of A's with E's. So you kind of want to get out of that class if your teacher's grading with a bell curve. Okay, so that's kind of the brass tacks of it. This is what a normal curve is. It looks like this. It's a bell curve. The mean, the median, and the mode are all in the middle, and the standard deviation is basically what controls the flow of all this. So what's important about it? Well, this is where we kind of break into what's called the empirical rule. I'm going to go ahead and draw a whole another bell curve right here. And so, how does this empirical rule work? Well, we also call this empirical rule, which I put on the very front, open page, to be 68, 95, 99.7 rule. And the reason why this is good is this. Let's say that, I'm going to go down here real fast. Let's say that we have a curve that is N25, 4. Okay? N25, 4 means this. You have N, mean, then standard deviation. Okay, so right now, the way that looks is we have a mean of 25 and a standard deviation of 4. So I'll just write that down here real fast. Mean 25, standard deviation of 4. So for my curve, well, and directly in the middle is going to be the mean slash median slash mode. That's going to be 25. Now for every movement out, and we always go 3, when I go to the right, I'm going to add 4 every single time. So that's 29, 33, and 37. And then I'm going to subtract 4 every single time. So 21, 17, and 13. So that is what our curve would look like under the constraints of having a mean of 25 and a standard deviation of 4. Now, if this truly is a normal curve, then the empirical rule states this. Between the first standard deviation on either side of the mean, so this is plus 1 minus 1, so one standard deviation on either side, contains 68% of the data. So that means currently, with our current information, that 68% of the data is in between these numbers 21 and 29. So, I mean, that could be anything, just as long as it's between 21 and 29 inclusive. It could be 22s, 23s, it could be 22.5s, anything like that. But 68% of the data would be in between 21 and 29. If you want to think of it in kind of a layman's terms, then you're talking about if there's 100 points of data, then 68 points of data would be in between these two data points. So if I go out further and say 2 standard deviations, so this is -2 plus 2, what we're going to get is 95% of the data. So again, 95% of the data is currently in between 17 and 33. So again, if you have 100 data points, it would mean 950 data points are in between 17 and 33. And then finally, 13 to 37 would contain 99.7%. So thinking of our 100 kind of doesn't work in this case because I don't think you're going to have 0.7 of a data point. But if you think 1,000, you would have 997 data points between 13 and 37. And so that's how a normal curve is set up. So that's kind of the basics. This is how I create a normal curve. This is what it's going to be. Now, suppose then I wanted to go out and figure out what is the percentage of data, say, between 17 and 25 or 13 and 29. Well, that's not so apparent because of there being just these particular intervals in particular. So what we need to do is we need to kind of break this down a little bit more to help us out. So same curve, we're going to rewrite the numbers down here. 25, 29, 33 plus 37, 21, 17, and 13. Okay, so what we're going to do is we're going to want to find the data below 21. So in order to do this, I kind of have to figure out first what is the percentages in between all of my little areas here. Well, if we remember correctly, this is 68% of the data. And if we also remember that the normal curve itself is symmetric and unimodal, what that means is that since it's symmetric, it's the same on both sides. So I can take this 68 and cut it directly in half to make 34%. Okay. Then I want to go out to these here. Well, if we recall from the last slide, this is 95%. So again, I'm going to cut this in half. So 95 divided by 2 is, let's see, half of 90 is 45, half of 4 is 2, and half of 1 is 0.5. So 45 plus 2 plus point, it's 47.5. So 47.5 goes from here to here. However, I already have 34% here. So what I want to do is I want to take that total 47.5 and deduct the 34. And what that gives me is 13.5. So 13.5 goes here, 13.5 goes here. Okay, then we're going to go out a little bit further. So remember we talked about on the other page that this was 99.7. I'm going to find this portion now. So we're going to do the exact same thing. We're going to cut 99.7 in half. So let's see. 90, half of 90 is 45. Half of 8 is 4. And half of 1 is 0.5. And half of 0.7 is 0.35. So let's see, that would be 90, no, that's wrong. That would be 49.8 49.85. Let me go ahead and confirm that real fast. Don't want to jump off deep end without doing that. Yep, 49.85. Okay, so that means from here to here now would be 49.85. So I take that and I deduct my 47.5, and I get 2.35. On either side. And they got to be the same thing, because remember, they have to be symmetric. And finally, the whole curve would have to represent 100%. Well, I've already got 99.7 between these two. So if I take 100 and subtract 99.7, that gives me 0.3. I then will cut the 0.3 in half, and that gives me 0.15 on both sides. Now, most people don't want to go through that whole process every single time. These percentages do not change. So if you can memorize that the pattern is 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.5, you will be accurate and on the money. So what does it help? How does it help us with x is less than 21? Well, if I look at 21 and I go everything less than it, then what I want to do is basically add up every percentage that I have that's less than that line. So I get 13.5 plus 2.35 plus 0.15. So when I add all that together, I get 16%. So what that tells me is that 16% of the data is below 21. And then I can keep doing things like that. So let's say that I want to do less than 33. Well, I can add everything up to that line, 33. I can also, coincidentally, if I don't want to add all this up, I can also do 100 minus these two, because that would give me all of that. Either way, I'll just go ahead and do the adding, just to emphasize it for right now. So if I add all those up, I get 97.5%. So 97.5% is less than 33. Now if I want to go the other way, so now I want to go greater than, so I want to go greater than 17. Well, all I gotta do now is look at that line and then go up. So let's see. And I'm pretty certain this one's just the same as number 2. And so that should give me 97.5%. Okay. So now I want to go greater than 37. So here's 37, and that one's easy because there's only one spot. So this one's really just 0.15%, quite a small percentage. And then if I want to do something in between, well, I would go between 13 and 29, and would add everything in between those. So 2.35 plus 13.5 plus 34 plus 34 gives me, let's see, 68, 11, 81.5, and then let's see, 83.85%. Okay, and then if I want to go 17, so 17 to 37, I'm going to add everything in between there, which you can trust me on this, is 97.35%. Okay, so that's how you would do that with those percentages. Now, What happens, though, when it's a number that is not on the actual graph itself? So sticking with this 25 to 4, what if I want to find x is less than 20? So I'm actually going to break out one of my notebooks for this. So I want to do x is less than 20. So I'm going to stick around with n 25, 4, which you'll remember this is the mean. This is the standard deviation. Also, when we talk about the population, the mean is considered the mu. Whoops, I can't see it. The mean is considered the mu, and the standard deviation is considered sigma. So when I want to find something like x is less than 20, what I'm going to do is I'm going to employ what's called a z-score formula, which looks like this. And I solemnly swear that that's not a 6, it's the sigma. So the mean, again, remember, is the mu. And the sigma is the standard deviation. So if I want to find x is less than 20, all I have to do is do 20 minus 25 divided by 4. Now, technically, you can also do this with the other numbers, and that's perfectly fine. So it just would come out a little bit differently with the method we're doing right now. But this comes out to be negative 5/4, which is negative 1.25. Okay, and this number is important. What we need is a decimal number, which is rounded to 2 decimals. So if it's not rounded to 2 decimals, then you're going to have to round it to 2 decimals. So the next step we're going to do is I'm going to pull out what's called a z-score chart. And so there's negatives and there's positives on the z-score chart. Now the number that I got is negative 1.25. So what I'm going to do is I'm going to locate both pieces of those numbers on this chart. But I'm going to locate them to the left and then on top. So negative 1.25. So negative 1.2 is right there. And then 0.05 is right there. And then what I'm going to do is I'm going to see where they both intersect. So if I look real fast, they both intersect at 0.1056. So what this tells me is that the percentage of data below 20 corresponds to 0.1056 or 10.56%. Okay, so let's say I want to do less than 27. Well, I do the exact same thing. X is less than 27. So I'm going to do 27 minus 25 over 4. So that gives me 2 over 4, which is 0.5. And so 0.5, if I go back in, now I kind of want to change this to 0.50 because I kind of want a number in front of the decimal and I want 2 digits after. If I went to go look at my z-score chart here, so I'm going to find 0.5 and 0. And that gives me 0.6915. Or 69.15%. So that tells me that there is 69.15% of the data below 27 in this particular case. Now, let's say I want to go higher. Let's say I want to go x is greater than 32. Okay, so 32 minus 25. We're still going to go the same route. We're still going to go ahead and plug it into a formula that's all the way back up here. 32 minus 25 equals 4. So let's see, that gives me 7 divided by 4, which gives me, let's see, 1.75. And I'm still going to look it up in this chart. So if I go back in here, let's see, 1.7, and then I think, oh, no, 1.75. I'm going to see where they intersect. I get 0.9599. So I get 0.9599. Let me just double check that real fast. Yep, that's what I get. Okay, so we're going to do something special here. Because I want greater than, and this chart always gives me less than, what I need to do is change this so that it's a greater than percentage. So what I'm going to do is I'm going to subtract it from 1. So anytime you need a greater than, subtract from 1. And so what I get is 0.040 or 4.01%. Suppose I want to get greater than 16. Same deal. I'm going to go ahead and do 16 minus 25 divided by 4. Let's see. That gives me, let's see, 9 over 4. No, negative 9 over 4. Which gives me 2.25 negative. Okay, so I look at my chart, and at this point, you guys can go ahead and start looking at, you can print out your own charts and look at it. But I get 2.25, so that would give me 0.0, or it's negative 2.25, so it would give me 0.0122 or 1. Nope. But I want greater than, so I'm going to do 1 minus 0.0122, which is 8.789 or 98.78%. Okay, so now suppose I want to go in between two numbers now, 18 and 30. Well, I'm still going to do the same thing for both numbers. I'm going to do 18 minus 25 divided by 4. And I'm going to do 30 minus 25 divided by 4. So let's see. 18 minus 25 divided by 4 is, let's see, plus 2 plus 5, 7. Negative 7/4. And let's see. 5 divided by 4. This will give me negative 1.75. This will give me positive 1.25. I don't know that. I think I did that one on the other page. Well, we'll do it again. But I'm gonna get. So I look up negative 1.75. That would give me 0.0401, and for 1.25, that would give me 0.8944. So I didn't do that last time. And then what I want to do with these two percentages is then I just want to subtract them. And so my percentage becomes 85.43%. Okay, so now let's, again, we got 20 to 34. So I can do 20 minus 25 divided by 4, and then 34 minus 25 divided by 4. Let's see, this gives me negative 5/4. That's the one I think I've done before, which is negative 1.25. And that would give me 9/4, which would give me 2.25. So let's see. That would be 0.1056. And 0.9878. And if I subtract the two, I get my percentage. Okay. So 88.22%. Okay, so that's doing that all by hand. So what happens if you want to use a StatCrunch to do it, which we totally can. So I got another set here. It's going to be a whole different normal curve. So we're going to look at, remove this for a second, normal 29/8. So take a look at that real fast so you can see it. And we're going to look at every single solitary one of these under that specific one. And we're going to look at how the StatCrunch does it. So let's flip over to StatCrunch, which, cross my fingers, so hopefully the screen capture will work really well. Better than the last one, hopefully. So if I go over here, we should have just popped up the StatCrunch. So where I'm going to go for this is I'm going to go to Stat, and I'm going to go to Calculators. And then I'm going to go down to where it says Normal, because we're dealing with a normal curve. And this is going to open up. Now this is really crucial. You got to set your mean first. So the last one I just did was 29 and 8 for the standard deviation. Now if we leave it alone, it should pop up. Let me hit the standard. Yep. If I hit compute real fast, it'll pop up just a normal curve. And you can hit it, so it gives you the 68, 95, 99.7 tick marks there. Now, I don't really need that right now. What I'm looking at is, for my first question, is less than 21. So what I want to do is I want to go here, and the less than and less than equal to, there's no difference. The equal to does not add anything to it, so don't worry about the fact that says equal to. I just want to type in 21, and it tells me that my percentage, and I'm going to write all these down and I'll show them to you when I get done everything, is 0.158 when we'll round up to the fourth decimal place, 0.1587 or 15.87%. Okay, and so my next one is less than 35. So I'm going to put 35 in and click enter to compute. And again, I get 0.7734 or 77.34%. You can probably see why a lot of my students prefer to use this one as opposed to doing it by hand because it's just so quick. Then I can go back and put in 49 for less than 49. And that gives me 0.9938 or 99.38%. Okay, now for this one, suppose I want to go to greater than. Well, all I got to do is click this guy right here and flip it to greater than. And then, so my next example says x is greater than 37. So I click 37, and bam, that gives me that one now, 0.1587 or 15.87%. Okay, greater than 24. Click it, and now I got 0.7340 or 73.40%. Okay, and then we got greater than 31. Click it, and now I got 0.4013 or 40.13%. Now, what if you want to do in between, like the other ones? Well, you got to click this button that says between. And then you're going to have to put both of them in. 13 and 29. Hit enter, and it gives it to you. So that gives me 0.4772 or 47.72%. How about 20 to 34? 20, 34, hit enter. I get 0.6037 or 60.37%. How about 16 to 30? Just type in 16 to 30. Hit compute, and that gives me 0.4977 or 49.77%. And realistically speaking, it doesn't matter if you have the percentage or the decimal; they're still considered the proportion of data. And just to make sure you go again, it's stat calculators, and then you hit normal, and then fill your stuff in. And then let's see, just so you can see, there's all of my answers right there. Okay, so let's suppose you kind of wanted to work backwards. Suppose the gas prices in Maryland are normalized at $2.35 with a standard deviation of 50 cents. At what price point would you be at the 80th percentile of gas prices? Now, if you wanted to do that algebraically, which I didn't really show in class, but I'll do one right here. What you'd have to do first is you'd have to take your z-score chart, and you would have to figure out which one is closest to 80%. So that's going to be on my positives over here. And what I would have to do is I would have to look inside for the one that's closest to 80%. And that would occur in between these two here. And so those numbers are 0.84 and 0.85. So what I would want to do is I would want to take the average of those two. And I would get 0.845 as my z-score. And then what I would do is I would then set up my formula. So this is my previous z-score formula to solve for x. And then we would have to do everyone's favorite thing in the world, algebra. So I'd have to solve for x. So let's see, 0.5 times .845 gives me .4225. And then I would add 2.35. So let's see. That would give me 2.7725. And since we're talking about money, we can give it an old round to $2.77. But my students aren't a fan of doing it the algebraic way. So you can actually do it the old StatCrunch way by going into Stat, going to Calculators, going to Normal. So you'd have to put your $2.35 here. And you'd have to put your 0.5 here. And then we want the 80th percentile. So we keep that at less than and just put 0.80 there. And it's going to give me $2.77. So look how accurate that was. Both times was $2.77. Sometimes you get it a little bit differently just because the StatCrunch is going to be slightly more accurate. It's going to take it and round it to better decimal places than we would. So that's why there's slightly more. Okay, so my next example states, and I'll switch it over and you can see it. And then I'll do it on StatCrunch. A couple is looking for a vacation, or looking at vacation packets to go to Hawaii. They find that the vacation packages are normalized at $3,500 with a standard deviation of 250. They would like to find the price that is no bigger than the 36th percentile. What price would that be? So I would go back here, put 3,500 here, put 250 here, and then in here I'm going to put 0.36, and that gives me the price is weird. It gives me the price is $3,410.38. I think yeah, that's taking. I have no idea why it's doing that. Let's stop it right now. Okay, so now we're gonna just cancel those out. Okay, that was weird. But now we got those two prices. So last thing, suppose I want an interval of ranges. So just going back to the same thing, suppose the gas prices in Maryland are normalized at $2.35 with a standard deviation of 50 cents. Suppose a focus group wants to look at the middle 80% of the data. What would be the price points to define the central 80%? Oops. Didn't want that to come up. But if I go in here again, I'm going to go between this time. I'm going to reset this back to $2.35 and 50 cents. And I'm going to go over here and just put central 80%. I'm going to put 0.8. And it's going to give me the two that's in between. So that would be $1.70, or really we round up to $1.71, to $2.99. Okay, so if I flip back, got it, and then we'll go to one more. So I want the central 40% for this one. So I go back. I hit that button again. It happens. Okay. Maybe Movavi will give me a endorsement. I don't know. But go back here, hit 0.4 for middle 40%, and that gives me $3,368 and basically 90 cents to $3,631.10. And that's pretty much it. Hopefully you got it.